Hello, everyone. My name is Christina, and on behalf of myosh, I would love to welcome you to today's webinar, 3 Brain Myths That Hinder Safety Performance. Now, today I am joined by the wonderful Cristian from HabitSafe, and we are absolutely thrilled to have you all here with us. Now, for over a decade, despite our continuous efforts, safety statistics in workplaces and on our roads have remained stubbornly unchanged. Today, we're going to explore why that might be and uncover the 3 brain myths that could be holding us back from achieving true safety excellence. Now, as we dive into this topic, we encourage each of you to participate actively. I will just mention we will be having a dedicated Q&A session at the end. So if you want to pop any questions in, feel free to do that. And if we get a chance, we'll address them at the end of the session. Please remember your input is always so invaluable. So we are grateful for whatever you contribute. Now, also a massive thank you to all of you who have submitted a question prior to today's session. A lot of the questions actually be covered in parts 2 and 3 of this series. So don't be discouraged if we don't get to them today. We will definitely get to them over the next coming weeks as we unpack more. Now, let's challenge some long-held beliefs, engage with the latest neuroscience insights, and work together to transform our approach to safety. Again, thank you so much for joining us. Now, let's get started.
Okay, thanks very much, Christina. A lovely introduction, and thanks for the opportunity to present today. So, look, I have a reputation for thinking about things differently. I like science, not pseudoscience, but real hard science. And the reason why I mention that is that I've seen lots of different approaches to safety, but I've always focused on where the evidence leads, which in my view is not always where safety ends up going. So today, I'm going to share with you where the evidence has taken me through scientific processes. And firstly, what I'll do is I'll set the scene, because I sort of give you an idea of why I'm sort of talking about this, and then we'll talk about the 3 main brain myths a little bit later on towards the middle. So if you talk about the human brain, that's what all human brains look like. All brains have the same structure and cognitive functionalities, but we're all individuals. Now, our individuality doesn't come about because we have different brains. Our individuality comes about because we've all experienced different things. And we may have experienced the same thing with a different outcome. So our brain houses everything that makes us who we are. Our hopes, our likes, our dislikes, our habits, what football team we barrack, all those things exist in our brain. It's what makes us laugh at a joke, maybe cringe if somebody says something inappropriate, or remember where we've parked the car when we go to the shopping centre. It's made up of 86 billion neurons or brain cells. 16 billion of those are on the outside. That's really the bit of the brain that you can actually see. And it makes up about 100 trillion connections. It's the most complex thing we know. Now, it consumes 25% of energy, but only totals 2% of the body mass. So it's a high energy use organ. And because the way the brain is today sort of came about from, 5,000 or more years ago, and when there wasn't a lot of calories floating around, the brain is concerned about trying to get things done with minimal energy use. So it tries to be as effective as possible and to use the minimum amount of energy to get anything done. Now, we have about 70,000 thoughts every day. More than 90% of those are exactly the same thoughts we had yesterday and the day before that. Now, we are creatures of habit. Because of the repetition and because we do things that are very familiar with us, what tends to happen is that we come across the same things over and over again. So the brain tries to use some neural networks and some other things which I'll talk about in a minute in order to get things done, because not only is it faster, but it's also more energy efficient. So if we ask ourselves, how do we end up with our individual wiring? We need to remember that the brain is locked in a vault of darkness and silence, our skull, and the only thing that it ever sees is electrical chemical signals. And they come about from the 5 senses. Now, the main job of the brain is to look at those signals and work out how to think about them, give them an interpretation, how do we feel about that, and act. Now, if we get the same sequence of electrical chemical signals over and over again, what the brain does is it doesn't want to go through that energy sort of intensive process of trying to work it out every single time. What it does, it creates a neural circuit in order to make things easier. So we all have neural circuits for all sorts of different things. We have a neural circuit for a chair. Now, the chair doesn't have to look the same. We know what a chair looks like. And associated with those neural circuits, we have an automatic pattern of response. We know that if we see a chair, we can sit in it. Now, it's not just an automatic pattern of response for that chair. We have these neural circuits and these automatic patterns of response for lots of things. So I refer to that as a pattern library. Now, the brain loves these patterns, these neural circuits and these automatic patterns of response because they're low energy use, they're pretty quick, and they tend to be a function of repetition, so we know that it works. But just because that's the case does not necessarily mean that they're the safest things we can do. So let me give you an example. So a friend of mine was driving and got to a red light, is in a highway, 3 lanes, he's in the middle lane, there's a car to the right and a car to the left. Now, the lights go green, he looks to the right, he sees a car coming at speed, he doesn't go. But the person to his right doesn't look, goes, and gets T-boned. Now, that is a perfectly controlled experiment. 2 people in the same situation, at the same time, in the same place. One avoided an incident, the other one didn't. What was the difference between them? Well, one driver was attentive in a way the other wasn't. That's not because they have different brains. That's because they have different wiring. And that wiring came about from their experiences. Now, the wiring in that incident and in many others makes all the difference. And we need to appreciate that our brain is live wired. But it's not sort of, the wiring is not concreted in, it's continuously changing. We continuously rewire on the run based on the outcomes. If it's a good outcome, we continue to do it. If it's a bad outcome, we stop doing that and we end up doing something different. So to think about the person that got sort of T-boned, he ended up with some nerve damage on his shoulder. He's going to be in pain for the rest of his days. What do you think he does these days when he's sitting at a red light and it goes green? Well, I know that person. We got to know him because we interviewed him because it was an interesting incident. We know for a fact he now looks before he goes. So most people rewire by waiting for life to teach them a lesson through pain. Now, that's one way to learn. It's not the best way, but it's by far the most common way. Fortunately, there's also another way, and that is what we repeat, we get to keep. So when we think about these neural circuits that drive so much of our behaviour, these automatic patterns of response, we can change those through repetition. And that's really one of the things that we help organisations do with their people. So we use the discoveries of neuroscience to prevent incidents, improve engagement, and move safety culture forward by teaching people how to detect and be on guard against the causes of avoidable inattention, because most of the inattention is actually quite avoidable. And we know what the causes are. There are 3 main ones. We also help people build attentive habits so they can prevent incident. So, like if you see the picture there, a person in a warehouse looking at the mobile phones when they're walking is not a particularly attentive habit. What does the habit need to be in order for somebody to pay more attention? And the last thing that we do, and the important thing too, is that we work with leaders to ensure long-term sustainability. So we don't want just to provide training and get people to come back and get us to do, follow-up or refresher or retraining. We want to set up a system in order for this to be long-term sustainable. So what we need to realise is the discoveries of neuroscience show that the human brain works in counterintuitive ways. Something safety has been slow to accept, in my experience. So we think our brain works like a scientist. We look at all the information and we come up with a logical, rational decision. Unfortunately, that's not how it works. It works much more like a lawyer. And what do I mean by that? Well, when we experience something, our brain interprets what happened based on what makes intuitive sense. That can be familiarity, consistent with other people's views that you like, whether it makes you feel good or not, and that's very much comes from the subconscious. The second step that happens is then we use our conscious mind to create a story to justify that, what we interpret to ourselves. Now, sometimes, and not always, we look at facts. If we do, we only tend to consider those that validate our interpretation. And that's why I like science so much, because it takes this process, shakes it about, and makes me sort of question what I think is going on. Because sometimes what I think is going on and what's going on are totally different. So although that's what happens in our brain, for all of us, it still feels like we considered all the relevant facts, weighed them up without bias, and came up with an interpretation based on objective evidence. And unless we challenge that about ourselves, we're always going to go with what feels good or what seems intuitively right, rather than what reality might be. So if we step back and we go, so what we term safety, what does that mean? Well, from my perspective, it sits on a spectrum. And the spectrum is anything from something that's pretty complex to something that's simple. Now, in the complex end, we've got process safety. I'm a chemical engineer by trade, and I've worked as a process safety engineer. So I kind of know that side of the spectrum pretty well. And, we use things like event trees and fault trees and bow tie diagrams and HAZOPs in order to make sure that things don't go amiss. Now, when you work as a process safety engineer, what you quickly realise is that things can escalate very quickly. So no one has enough cognitive horsepower to be able to foresee what can happen and do something to stop it. So we tend to work around the person because we can't really rely on the person. On the other side of that spectrum is personal safety. And personal safety is a very simple interaction between a hazard and a person. Now, there are incidents to both sides of that spectrum, and some of them sort of a good deal in the middle. If I said to you, if you look at the accidental fatalities in Australia, would it be mostly down the complex end or would it be mostly down the simple end? Now, I've looked at that and I can tell you that for every one down at the complex end, there are 20 at the simple end. And that's not the worst piece of information I'm going to give you today. If you look outside of work, there's 500. Because most of the stuff that happens to us outside of work is a very simple interaction between us and a hazard. If you want to look at the Australian data, you can check it out. It's been that ratio for the last 5 years at least, possibly the last 10. So the question that we ask when we talk to safety professionals is, where do you want to have an impact? Because if the only thing that you're doing is stuff around the person, then you're certainly going to cover the process safety side of things. You may also cover a fair few of the at-work scenarios, but you're not going to do a hell of a lot for what's outside work because we don't really have control over what happens around the person. So it's not just about dealing with a hazard, it's also getting people to start looking at the person side of things, at the human factors, and trying to help them bring those under control, or at least give them something to be able to deal with those human factors a little bit better. So if we only look at incidents from work, we get an incomplete understanding of all contributing factors and a limited range of potential solutions. So if you only look at the incidents from work, you are ignoring 96% of the data. And because you're ignoring 96% of the data, you end up with a biased view. And a biased view that doesn't really help that much. So for me, I'm interested in safety 24/7. So not just at work, but outside of work as well. So when I look at the data, and I also look at the incident investigations that I've done over the years, which are probably a few hundred, what I've noticed is that 95% of incidents have some form of avoidable inattention as part of them, which we could address. But if you're only looking at incidents from work, then you don't tend to have a look at what's going on with the person and helping them with some of their human factors. So if we go back and we go, I told you I like science, so the simple physics of safety incidents, even SIFs, what we're trying to prevent is this interaction, because when that interaction happens, we get harm. And the purpose of safety, from my perspective, is not to allow harm to happen or to minimise it as much as possible. So if you go back to the 1970s, before safety was a thing, and you looked at this, and your boss rang you up and said, look, we want you to have less incidents, what can you do? Well, the first thing that we started doing was eliminating hazards. If the hazard's not there, the interaction doesn't happen, you don't get an incident. It didn't take us long to figure out that you can't get rid of all the hazards. So then we started looking at, what can we do in order to provide controls? Something in between the hazard and the person, so that the interaction may still happen, but harm doesn't take place. And that's how sort of management systems came about. Now, after 10 years of doing that, we had the idea of, okay, hang on a minute, there's also the person that's involved in this interaction. What can we do with them? And we assumed that because safety is important, we should be able to keep safety front of mind. That's about giving people conscious control. Unfortunately, that's not how the brain works. What we now know that we didn't know then is there's a whole bunch of wiring in the subconscious that determines most of what we do. But when you look at history and you think, what have we been doing over the last 50 years? It's been mostly those three things. Over the last decade or so, we really haven't been doing much of that. If you remember behaviour-based safety, initially it worked well, but as people became familiar with it, it was more and more difficult to get people to keep safety front of mind. So we do things around the worker, and that's a good thing. We also do things with the worker, or we could be doing more things with the worker. And sort of behaviour-based safety is no longer floating around as much as it is. Most organisations don't tend to do anything about the human factors and some of those subconscious sort of things that drive people's behaviour. So we tend to be doing more of the stuff that's hazard-related rather than the stuff that's person-related. Now, you appreciate too that the majority of fatalities and serious incidents, and even some of those other incidents, are not about complexity. There are complexities about them, but it's not about complexity. It's fairly simple to try and keep the hazard and the person separated. Now, look at what we've done. This is the Australian work fatalities since 1980, and you can see that in the 1980s and the 90s and the 2000s, we were able to reduce the number of fatalities significantly. But since about 2010, not much has happened. And certainly no improvement since 2013, although we do more for safety and we do it better than we've ever done it before, but we tend to do exactly the same things. We're stuck in a zone of diminishing returns. We keep doing the same things, expecting a different result, but we're not making much of an impact. When you keep doing the same things, expecting a different result, and you're not getting much of an impact, to me, that's the definition of insanity. And that's why I'm interested in what is it that we're actually missing. So the problem as we see it is that we have relied too much on doing things around the worker and exercising conscious control without giving enough consideration to what we now know is actually going on in the human brain. So new research maps brain activity as it happens. You're probably familiar with an MRI. I've got problems with my knee. I go to my doctor. He sends me off to an MRI. He gets back a picture. So he looks at it and he goes, Christian, you've got fluid in your knee. This is what we need to do. That's fine. What you're probably not familiar with is a functional MRI. A functional MRI doesn't give you a picture. It actually maps blood flow as it happens. So a neuroscientist can look at it and determine what's actually going on in the brain. So think about this. For the first time in human history, we're able to see what's going on inside people's brains as it happens. And what it's telling us is that a good deal of what we assumed about how the brain works is either incomplete or incorrect. So let me give you an example. If we put your head in a functional MRI, and while you're in there, we show you a picture of a snake, your amygdala lights up like a Christmas tree. Why? Well, because that's one of the parts of the brain that registers threats. So because the amygdala is being used, the blood flows there and you can actually see it on a functional MRI. What we didn't know, that's interesting, is that once that happens, blood flow to the prefrontal cortex, this thing here behind your forehead that regulates behavior, diminishes. It diminishes to a point where there is enough blood in order for the brain cells to stay alive, but not enough blood in order for them to function. Essentially, sidelining your ability to regulate your behavior. So the other thing, and that's why when people feel threatened, they lash out. And in hindsight, they regret it. Because at the time, it's very difficult to regulate your behavior. If the part that regulates the behavior isn't working. What we've also learned is that brain chemicals come into play at crucial moments, like when we're stressed, rushing, frustrated, irritated, that kind of thing, when we're fatigued or tired. And other brain chemicals help us pre-program our autopilot activities so we can deal with things that are familiar to us in a much more energy efficient way. The problem is, of course, is that these brain chemicals, we never had any idea that these brain chemicals control what we do to a huge extent and help us explain why people do what they do. So the problem is that these brain chemicals tend to happen below our level of conscious awareness. And because they happen below our level of conscious awareness, we give them absolutely no credit at all. But neuroscience shows that up to 95% of what we do originates in the subconscious. So it originates in a place that we're not aware of. Now, that begs the question, is what drives what we do? So whenever you think about behaviour, whether it's for safety or for other reasons, I want you to think of it in this way. This is the conscious mind, so that's what we're aware of, and we exercise control with it. Behind it is a huge, powerful subconscious with a whole library of automatic patterns of response, stuff that we end up calling skills and habits. And either of these two can actually influence behaviour. If it's new or different, it tends to favour the conscious mind. If it's familiar or it has to do with stress or fatigue, it tends to be the subconscious. The problem, of course, is this one is the only one we're aware of. So we think that is all there is. So when you look at the neuroscience, what you find is that there are four main brain operating modes that determine most of our behaviour. We have conscious control. You have autopilot, and I tend to refer to autopilot as complacency because we tend to use inattentive habits mostly. There is the stressed aspect of it, rushing, frustration, fatigue, that kind of thing, and also fatigue. If I asked you which one determines what we do most often, which one would you pick? Now, for the last 50 years or so, we've assumed it's that one in safety. But the neuroscience is clear. There is enough neuroscience to sink a battleship on this one. It's not that one. The brain operating mode that drives most of what we do is this one. Why? Because most of what we do is familiar. So if it's familiar, there's a neural circuit associated with it and an automatic pattern of response. So the brain operating modes are our main biological default settings. So the conscious mind is like the screen on a smartphone. We think it does everything. But the subconscious is the electronics behind it that make it all happen. But unfortunately, on our smartphone, we don't see the electronics. So we tend to only focus on the screen. Now, we have the perfect default settings for human life 5,000 years ago because our brain really hasn't changed for 5,000-10,000 years. Now, back then, it was mostly routine tasks with very few distractions. Now, brains don't behave badly. It's just that the default settings were not designed for modern life. We haven't evolved and adapted. It's much busier and we have many more distractions. But like our smartphones, our brain's default settings can be adjusted for modern life once we actually understand how our brains actually work. So our brain assigns the default settings based on how it interprets what the world does to us or what the world throws at us. So if what the world throws at us, it's new or different, then it gets the conscious mind involved and we need to focus and think. but that's energy intensive and it's slow. If it's something familiar, then it goes with a complacency or autopilot mode, and we tend to use inattentive habits. Not always, but the majority of the time. If we're short of time or something's in our way, that's about stress, rushing, frustration, irritation, and we end up taking shortcuts because we can't regulate our behaviour particularly well. And if we're low on energy, that's really very much about fatigue, and we end up making poor in-the-moment decisions. So the process that the brain uses is that it interprets what's being thrown at it, and it usually tries to get it into one of those 4 boxes. Is it new or different? Is it familiar? Am I short of time or something's in my way? Or is it low on energy? Once it interprets, it assigns a brain mode. And once it assigns a brain mode, we get a certain brain functionality. And that's what we have to work with. Now, the interesting thing about this is that 95% of what we do is driven by the subconscious. And this process happens without our knowledge, without our awareness, and without our permission. If you like, it's programmed in. But it doesn't mean that we have to live with it. There are things that we can do in order to tweak it for modern times. So when the subconscious drives what we do, conscious control drops off naturally, increasing avoidable inattention, and we end up having more safety incidents. So does the shade of grey on the top and bottom panels look the same? So if you look at that, does the top and the bottom look the same? So for most people, the top looks darker and the bottom looks a little bit lighter. But if I do that, what we find is the shade of grey is exactly the same. The person that put this together used the same shade of grey. Now, you know, I'm a consultant, so I can't be trusted. So what I want you to do is I want you to use your fingers and convince yourself that that's what happens.
That's incredible, isn't it?
Yeah.
It's like those viral blue dress, gold dress on, or like, what colour is this shoe or something like that?
Well, we'll take a look at the dresses in a minute, to be honest.
Oh, sorry.
That's okay. That's fine. So
I moonlight as a psychic.
So why does it happen? Well, it happens because it has a lot to do with how we interpret shade. So this is an object lit from above. We've all seen many objects lit from above. If we're outside, right, the sun is up the top, everything's lit from above. If we're inside, lights tend to be in a ceiling, so everything that we see is lit from above. And so there's a pattern that the subconscious brain creates for itself when it looks at something that's in shade. And in order to make this image fit the pattern, it needs to make the top a little bit darker and the bottom a little bit lighter. And that's exactly what's happened. If I ask you, is this 2D or 3D? It's on a screen, so it's a 2D image. But we all interpret it as 3D because there's certain cues there. There's a horizon, there's some shade, that kind of stuff. Did I ask you to interpret it as 3D? No, nobody asked you. You just do that automatically. Right. So, and the reason why we do it automatically because of the cues and this pattern matching that takes place in our subconscious. So the subconscious usually pattern matches first. If it can't find anything to pattern match with, then what it does is it brings the conscious mind into play. So some people believe that you can consciously override what the subconscious does for you or interprets for you. So let's put that to the test. Can you will the top and the bottom of that, whatever it is, that suitcase, to look exactly the same shade of grey without covering the cues and without squinting your eyes so that your brain doesn't know what it is? We've done this with over 1,000 people. The only people that tend to think that they can do it are usually under the influence of drugs or alcohol. Most normal people can't do it. And the reason why they can't do it is because it's very difficult for the conscious mind to override what the subconscious interprets for you. Not just visually, but also when it comes to your behaviour. So you consciously know that those two shades of grey are exactly the same, but you can't do anything about it. It's like you know the answer to the test, but you still keep getting it wrong. Now, although seeing is an approximation, it's still one of the simplest and best things our brain does. Now, 70% of the information that the brain processes comes in through the eyes. Now, the subconscious mind constructs what we see by comparing it against what it experienced previously. And it's not just what we see, it's also our behaviour as well. So there are the dresses. Now, why do people see the dress coloured so differently? So there was some research done here. And what they found is the people that saw the dress as gold and white spent more time outdoors. The people that saw it as black and blue spend more time indoors. So what happened is each person created their own neural circuit, their own sort of automatic pattern of response. And when they saw an image, because those two sort of were developed in different parts, one in outdoor light and one in indoor light, they interpret the environment and what's placed in front of them differently. So although it feels like we're always reacting to the world, our brain is a prediction machine that enables us to respond quickly to situations. Now, because it predicts, it can't always be 100% right, but most of the time it's right enough in order for us to avoid danger, or at least, 5,000 years ago. Because the survival 5,000 years ago, quick was much better than right when there was danger to avoid. So our brains haven't changed. So that functionality is still with us, is still part of us, but doesn't serve us particularly well in a modern society. So let's look at the first brain myth that hinders safety performance, and that is that knowledge is enough to do things safely. Now, I get that knowledge is part of it and people need to know what to do, but it's not enough by itself. Now, if you've done so the way that this kind of brain myth manifests itself, I see a lot of incident investigations where the corrective action is retraining or refresher, as though we thought that people momentarily forgot what they needed to do. Now, if people knew what could hurt them, they would avoid it. Most of the times they do. But unfortunately, that's not always true. Out of the few hundred incident investigations that we've done, hardly any of those involve somebody that didn't know what the hazard was and what the control was. They knew, it's just that something else was going on that influenced their behaviour. So knowledge is good to have, but it is used primarily by the conscious mind. Most behaviour is driven subconsciously, so knowledge is not always enough. So to give you an everyday example, many people know they have high blood pressure or high cholesterol. They know how to fix it. It's easy. You have to eat better and you have to exercise more, but yet most don't change what they eat or how much they exercise. The reason why they don't change is because what we eat and how we exercise tends to be subconscious. So the fact that you know is helpful, but you have to use that conscious mind in order to change your habits. So knowing what can hurt us and how to avoid it is good, but it's not enough because it only influences the conscious mind. And our behaviour is mostly driven subconsciously. So if you go back to the little exercise we did with the different shades of grey, what we know is that the conscious mind does not override the subconscious. So we need to find a different way to deal with it. The second brain myth that hinders safety performance is that people can consciously control their safety. Oops, sorry. So sometimes people say, look, if safety is a value or if safety is really important, then people should be able to think about it consciously more often. And that is true. And that is a good thing to do. But not as much as what we have thought as far as safety is concerned. So if we go back to behaviour-based safety, when it first got introduced, there was some really good incident reductions. It worked. Why? Because the conscious mind is really good when things are new or different. But as time went by, Familiarity started to come into play, and then it was really difficult to get people to continuously focus consciously, to keep safety front of mind and to think safety continually. It's good to do, but it's not the main game that your brain's playing. So if people thought about safety when they did something, they wouldn't have incidents. That's true. Problem is that that's not the way that the brain works. The conscious mind comes into play in the moment where something is new or different. And that tends to be about 5% of the time, according to the brain science. Most things we do are familiar to us, so we do them in autopilot using existing habits. If we try and get the conscious mind into the game of something familiar, what we're doing is we are picking a fight with our biology. And that is a fight we can't win. It becomes increasingly harder to do that. And I think that's what happened with behaviour-based safety. Now, sometimes stress and or fatigue can also influence behaviour. Now, that's the other aspect that sort of disrupts when autopilot or when the conscious mind is in play. So let's do an experiment. Which mind is in control of our breathing? Well, our breathing happens without us having to think about it in the moment, so it's obviously controlled by the subconscious. Can we take conscious control of it? Can you make yourself breathe deeply or more shallow or faster? Of course you can. But how often do we do that? Not very often. Why not? Well, because there is no point when the subconscious does it well already. And that's why the conscious mind stays out of a behavior that's already driven by the subconscious. If the subconscious is already in control, why do I need the conscious mind to get involved? So the same thing applies to our behavior. So most of what we do is similar to us, so it happens without us having to think about doing it in the moment. That's what makes it subconscious. Can we take conscious control of it? Of course we can. How often do we do that? Not that often. Why not? Well, because there's no point when the subconscious does it well already. So to give yourself an example, think about the most dangerous thing you're going to do today. It's probably driving home. Right? When you're driving home, how much of the trip is your conscious mind thinking only about driving? Now, you can make yourself do that, but it's hard, right? And you're going to be tired by the end of the drive. Right? So the conscious mind does something else when the subconscious is in control. Right? And most of what we do is familiar, because I've done it plenty of times before, so it's driven subconsciously, even though it feels like we're making conscious decisions along the way. So when something becomes familiar to us, the subconscious brain modes take over, and the conscious mind focuses on learning from the past or preparing for the future, because it doesn't need to be in the moment. So I talk about the fact that the conscious mind time travels. When the subconscious is in control, it can afford to learn from the past, it can afford to look into the future to see potentially what could be something that could trip you over and some precautions that you may take. That's what it's good for. And the third brain myth that hinders safety performance is we can't do anything about inattention. And the reason why that one comes around, I think, is because we're only aware of the conscious mind, we think that all attention is consciously controlled. Now, what the neuroscience shows is that the majority of our attention is allocated subconsciously through the subconscious brain modes. So let me ask you something. When we're inattentive, what's the most common safety consequence? Now, most people will say an incident of some kind. Do you agree?
I was going to say injuries, yeah.
Well, most people say some incident of some kind, right? Because we do this as part of our training. Hardly ever does anybody give the right answer at this stage. Now, an incident of some kind is not the right answer. So if you start asking yourself, well, if an incident of some kind is not the right answer, what's the right answer? The right answer is no incident at all. So think about it this way. If most of the time when we're inattentive, we had an incident, what would we teach ourselves to do? We would teach ourselves to be more attentive. We would teach ourselves to pay attention. But most of the time when we're inattentive, nothing happens. And because nothing happens, we repeat the inattention over and over, even if it's avoidable, because most of it is, and we end up with inattentive habits. Now, once we have inattentive habits, the attention is actually subconscious. You're tied it to something else. So those people that you see there, their attention is on the phone. If that's the first time they looked at the phone when they were walking, it's probably a conscious decision. But the 100th time they've done that, it happens automatically. And of course, the big issue with this is that we don't even know about it. And because we don't even know about it, it makes it a huge blind spot. And what we know is that people that have a huge blind spot do nothing about it. So part of the training that we do is to make people aware of these things so they can start looking for it. When they see it, we can teach them what to do about it. So neuroscientific research has identified that the main causes of avoidable inattention, and they're the subconscious brain modes like stress, fatigue, and complacency. So we know what they are, and also what can be done to minimise it by up to 90%. Now, we cannot be 100% attentive 100% of the time. I wish we could, but that's just not the way the brain works. However, we can be a little bit more attentive when it matters. And if we're a little bit more attentive when it matters, that can be the difference between a glancing blow and a direct hit. And that's really what we're trying to teach people to do better. So knowledge and conscious control, they're useful things, but not by themselves. Now, they play a role in helping people minimise inattention. So, for instance, if we have a new or different experience, right, call it knowledge. I'm not sure if you've ever seen anybody almost get run over at a street crossing because they're looking at their phone. You ever seen anybody look at their phone while they're crossing the street? It's not rare. Because it's new or different, the conscious mind gets involved. And then hopefully we get an insight. We realise that change is needed. Initially, we start to consciously look both ways while crossing. So we make ourselves do it. Right? If we continue to make ourselves do it, call it practice, we get to a point where there's a new neural circuit that enables a safer skill or habit. When that happens, if there's enough repetition, we can look both ways while crossing, and it happens automatically. What that means is it means that we don't have to rely on reminding ourselves or remembering to do it. It's now wired in. And that is the huge benefit of dealing with the subconscious, is once you wire these things in, you don't have to think about it, you don't have to worry about it, they happen automatically. One of the things that I do sort of come across a lot is this sort of the environment drives behaviour. That is true, but it is also misleading. And the reason why it's misleading is because there's two environments, not just one, and both of them can be changed in order to help people be safer. What most people talk about when they talk about the environment drives behaviour is the external environment. The world generates a situation around the worker. The reason why the worker did whatever they did was because we made them do it. And sometimes that is the case. So you can change that in order for it to happen less often. There's also the internal environment, because we can rewire what's going on in people's heads through repetition. So we can rewire the way a worker interprets a situation and assigns a brain mode. Because once it assigns a brain mode, that's how the behaviour happens. It responds from the specific brain functionality that comes into play from that brain mode. So for me, if you want to get better at safety, if you want to improve safety performance, it's not just about dealing with the external environment. It's also helping people rewire what's going on inside their heads, so that when the external environment isn't treating you as well as it can, you've still got a level of protection that maybe is not there for somebody that didn't do that. But unfortunately, the way that safety is headed, from what I can see, is that it's all about the external environment. They don't want to deal with the person at all. So when we don't help people rewire internally, we lock out our most valuable asset from the opportunity to be more in control of their own behaviour. That's what I think happens. Now, if you think about human nature 101, the more we do for them is that the less or the more they do for themselves.
I'm going to say less.
Yeah, it's the less they do for themselves, right? And that's kind of the way that humans are. We take the easy path. So I don't mind if we go around and do things around the worker. I think that's a positive thing to do. But if that's all you do, then you're really helping them be more inattentive, right? Because why should they pay attention? It's not their problem, it's somebody else's. Right? So we can't do anything about inattention is the most damaging brain myth of them all. When we only do things around the person, we are helping them be more inattentive. And when an incident happens, they are more likely to play the victim. We've seen that in incident investigations that we've done. So we go in and we talk to them about, and usually I sort of start an incident investigation by saying, look, this is not part of the formal incident investigation. That would deal with what the organisation needs to do in order for the incident not to happen. What I'm interested in is what was going on with you. So what was different about this time? And when you ask that question, and they've gotten an incident based on something they've done plenty of times before, it usually comes back with either complacency, rushing, frustration, irritation, or fatigue. So without intending to, if we only do things around the worker, avoidable inattention increases over time, and that results in more incidents. And then you have to do more things around the worker. That's the way to go. Not my preferred way to go, but that is the way to go. So to improve safety performance, what do we need to do? Well, we need to improve our ability to influence. That's the first and foremost. And that's about showing care, building trust, being inclusive, psychological safety. But if that's all you do, that's a panacea of wishful thinking. You've got to do more. And what we've got to do is we've got to address all the areas that impact safety. Every time we eliminate hazards, it's a good thing. Every time we improve controls, improve the system, that's a good thing. Every time we get people to think more consciously about safety, that's a good thing. But we also need to work with people in order for them to manage their subconscious brain modes better. Because what we've noticed and what the research shows is that if all that stuff that you see on the left-hand side, show care, build trust, be inclusive, psychological safety, avoidable inattention trumps all of those. So that by itself is not enough. So when you think about what is it that we're actually trying to do here, improving our ability to influence, that's things we do around the worker, that's a good thing. Eliminate hazards and better controls, that's also things we do around the worker, that's also a good thing. But we also need to start doing things with the worker. And that's an internal thing. And conscious control stuff we've done through behaviour-based safety. Lots of organisations aren't doing anything to help people manage their subconscious brain modes. So for us, good safety leaders address everything that impacts safety, not just the things that they feel comfortable with. So when it comes to the subconscious brain modes, we can't always rely on the world around us to do the right thing to keep our people safe. Your supervisors, your managers, they're human. They're going to have a bad day and they may say something that entices somebody to get into a subconscious brain mode, or they may say the wrong thing. So we also have to teach them how to deal with each brain mode for themselves. So that is the second line of defense when the world doesn't do the right thing to keep them safe. So at HabitSafe, we're committed to people's safety 24/7, not just at work. And the good news is that the subconscious brain modes go with us everywhere. So if we improve them outside of work, they also come to our rescue at work. So next time, we're going to take a deeper look at autopilot, complacency and habits, the main drivers of human behaviour. If you're interested in this stuff, there's a book that I've written. You can go to our website. You can get the first 3 chapters for free. It's available electronically from Kobo if you want to. There's a podcast, about 6 or 7 that we did called Safety Frontiers, or if you wish, you can look me up on LinkedIn. So Christina, I'll hand over to you to see if you want me to address any questions.
Amazing. Thank you so much. I will also, if it's okay with you, Cristian, I'll send out these slides as well to everybody, as well as the links to join us next time when we go over autopilot, complacency and habits. Now, just going over a few of the questions, like I said before, based on what people have asked prior to today. There are a few ones that I thought would be great to chat to now, rather than the ones that we might go over later. But I guess one of the main ones, which you sort of just touched on at the end there, was how can we sort of engage decision makers so that they are willing to invest real time into learning about this sort of new way of thinking about safety?
Well, look, I guess that the issue with what I talk about is that it's not mainstream safety. So somehow you need to try and get this stuff in front of them. There's plenty of books about the brain that you can give people so that they can read. If people are interested, I'm more than happy for them to contact me, and I will do a half-an-hour session for management in order to give them a broad brush appreciation of what we do and how we do it. And that might be enough to get them sort of interested in maybe looking at this as something that they may wish to do.
I often find as well, not even just in terms of like safety, but in terms of anything really that you kind of need to get your point across with, you kind of need to know exactly who you're talking to and what they value as a result from anything. And if they understand, if you sort of know what they would be looking for, like if you go to the CFO, you're gonna direct your questions and your information to them differently to what you would to your colleagues, sort of thing. So it's chatting to you about all of that would really help.
Yeah, it's horses.
Yeah, exactly. We might have time for one more question. Let me just double check. Yeah, easy. So another one. Oh, this is interesting. When errors are unintentional, is it possible to realistically intervene?
Absolutely. I mean, most errors are unintentional. People are not meaning to make mistakes. They're certainly not meaning to have incidents. So the interesting thing for us is that when avoidable inattention's in play and they have a bad outcome, that tends to be spoken of as human error. So for us, and I talk about inattention because I think that is a much more interesting concept to try and get people to understand that than human error. With human error, sometimes what you get is you get blame and fault and all that kind of stuff, and that's not helpful. I mean, the stuff that we do has got absolutely no blame in it at all. What we're trying to get people to do is to understand what's going on in their heads better and practice some techniques so that it doesn't catch them out as often. So, when people talk about sort of errors unintentional, I kind of think about, well, I think they're all unintentional. I mean, sometimes you can, in hindsight, you may sort of wish that you had done something differently, but at that time, with whatever was going on in your head, you never meant to make a mistake. It just happens because of what was going on at that time. So whether it's intentional or unintentional, our view is that we need to reduce the amount of avoidable inattention. If you reduce the amount of avoidable inattention, people will make less mistakes, there will be less error. And that's where we're trying to head organisations to.
Amazing. All right, one last question, because it interests me as well. Being easily distracted myself, this goes for both the person asking the question and myself.
You?
Well, no, somebody actually asked this. I was like, I could have written this myself. So being easily distracted myself, I wonder if any studies have been done with workers in different settings where repetitive work is being performed to indicate what the optimum duration of a single task should be before your attention starts to wane.
Right. So do an experiment when you get in your car. How long does it take you to feel comfortable enough to start thinking about something else? Hardly any, right?
Yeah.
So sometimes what people do in order to overcome things like complacency, and we'll talk about this next time, is they try and change the things that people do. And intuitively, that's a good thing to do. The problem is that if you get people to do something that they're really familiar with, it takes them very little time to get comfortable enough in order for complacency to come into play. And that's the issue. So people try to address things like complacency by getting rid of it. And unfortunately, you can't do that. It's part of our default setting. It's part of our biology. If you try and get rid of complacency, what you do is you pick a fight with your biology and you lose. So what we do is we accept that people are going to do things in autopilot, and what we try and do is we try to get people to have safer or more attentive habits. And it depends on what the person does. So if the person's doing some assembly, looking where you put your hands is a pretty important habit to have. But I've gone and visited manufacturing sort of facilities where people are looking at the ceiling while they're working with their hands. And that's the habit that they develop. Now, most of the time, nothing happens. But if there is an incident, you go, where were you looking at when you had the incident? Most of the time, people aren't looking at their hands. So when you think about, that interaction between a hazard and a person, if you can get the person to look before they move, whether it's their body or, their hands, and you can get them to look for the line of fire, they're going to see it earlier. If they see it earlier, they've got more chance to get out of the way and not get hurt. And that's really what we try and do.
Wonderful. Well, I think that's all we have time for today. Like we keep saying, there are another 2 webinars in this fabulous series, all about neuroscience and human behaviour. And Cristian, again, we can't thank you enough for joining us and taking your time with us out of your busy week. And again, thank you to everybody that's joined us. I will send everybody a copy of our slides today, as well as links to everything that Cristian has mentioned and registration links to the next 2 webinars too. So please send through any questions. If you need to get in touch with Cristian, his email address and phone number are on the screen now. If you want to take a screenshot or a photo, I know he'll be happy for you to reach out at any point. And if you need anything from myosh at all, please reach out to us as well. We're always around and happy to help. So again, thank you so much, Cristian and everybody, and I hope you have a wonderful rest of the week.
Thanks very much, Christina, and thanks everybody for coming along and listening.